and some of these concepts are review. I know that. Okay, so right here, there are three main sections of this unit. So first, we spend time on three-sided polygons, which we know, you know them as triangles, right? So, right, you have your triangles, every different shape you can possibly imagine. Okay, so we'll stick with triangles at first. Okay, then we will move over to four-sided polys. I'll just go polys so that it fits in, and I'll zoom in a little bit to that so you're not squinting too much. Four-sided, so those are your parallelograms, your square, right? It could even be a kite. It kind of looks like a diamond, but it's not, right? And so those are what we call, watch this word, quadrilaterals. Okay, quad is four, right? Four-sided polygons, right? So we have a specific name for them. We refer to them as quadrilaterals. So we're going to spend some time on triangles and their properties and how to name them. Then we're going to spend some time on quadrilaterals, properties, and how to name them. And then last but not least, it's just going to be polygons in general. Okay, poly means many, gons is angles, so many angles. And so there you have everything. You could have a pentagon, five-sided, right? You can have an octagon, which is your stop sign, right? But you could also have a triangle. A triangle is technically also considered a polygon. So is your squares, right? So it kind of mixes everything together. So then there's something particular about these, and then just in general. That's when you get to see formulas and stuff when we do polygons. And so if you have your formula sheet, this unit has significant amount of information on this formula sheet. So the yellow, if you bring your blue and your yellow, right, then you'll have a lot of stuff. And if you need more, another yellow, I have some extras, only if you need it. So that's the overview. That's what we're going to kind of do over this unit. It's a shorter unit. Hopefully we're done by spring break. I would not like it to have to study over the break and then come back and do it. So we'll see. Okay, working with triangles. We're going to review Pythagorean Theorem. This is just a review, I know that, okay? And every teacher has a bit of a different spin on it, but they're all saying the same thing. Mark my words, the first side you always find is the hypotenuse. Where is the hypotenuse? It's across the 90. So you find the box, you go across from it, that is called the hypotenuse. It's the longest side. No surprises there, right? The other two sides are called legs. So you call this leg, and this is the other leg. Don't worry about the letter. Worry about, is it the hypotenuse or is it a leg? Ah, that's a good question. Opposite and adjacent is when you're using sine, SOHCAHTOA. Do you remember SOHCAHTOA? Sine, cosine, tan? Only then. So don't worry about adjacent and opposite and any of that, okay? Toss it in the bin, right? Gone. So here we go. There are two, listen carefully, it's very simple actually. There's only two scenarios. You're either missing the hypotenuse or you're missing one of the legs, okay? If you're missing the hypotenuse, right? If that's the one you don't know, then it's like this, watch. Hypotenuse squared is equal to leg squared plus leg squared. So to get the hypotenuse on its own, what do you need to do? Square root leg squared plus leg. So that answer you get when you square them, you square root that. That's it. This is the formula I'm going to use right here, this one. Okay? And then next, if the second scenario is you're missing a leg. Right? If you're missing a leg, question mark, then it would look like this. Leg squared is equal to hypotenuse squared. But what's going to be different here? You're going to subtract the other leg from it. Always squaring it, right? So to get the leg that you're interested in, you're going to square root hypotenuse squared minus leg squared. So these are your two formulas for Pythagorean theorem, and it works every time. Make sure you identify the hypotenuse. That is the important thing. The other two are the legs. There's no question about it. And it's always across the 90, and the hypotenuse has to be the longest. If you don't have that as the biggest number, you made a mistake. Okay, and just a note, only works with right triangles. And you need 2 out of 3 sides, right? You need to know 2 out of the 3 sides to get this to work. This is the blast from the past, right? I know you've all done Pythagorean theorem in some way, shape, or form. Okay. Why am I introducing this? Because quite often you're going to have a right triangle in this chapter. So often this is the quickest way of finding that third side. And notice that the only angle you would know is the 90, which we don't really use, right? You would be like, oh, can I use sine law, cosine law, Mr. Dirksen? Absolutely, that still works, but it's not always the fastest. We're good? Okay. Next page, 175. And there's that dreaded SOHCAHTOA. This is what we're going to do. Cross it off. Right? 175 at the top. Don't use. I'll say this. You wouldn't lose marks if you use it correctly, but there's a big risk of you getting it wrong. So I would say just don't use it. Use sine law, cosine law instead. And here you have an example, first example. Calculate the length of the missing side. Right? It's a right triangle, check. I have 2 out of the 3 sides, check. So I can use Pythagorean theorem. Watch this. I find that this is my hypotenuse. Don't worry about the letter so much right now. Call it the hypotenuse. That means that this is a leg, this is another leg. It happens to stand the exact same way as the other one we just did. So I'm missing this. So I have to use the first version of that formula, which is hypotenuse squared is equal to leg squared plus leg squared. This is the one I have to use. So let's substitute. The hypotenuse happens to be called A. One of the legs is 7.6 squared. The other leg is 9.4 squared. Go ahead and type that in. So line 1, line 2 is, we're going to square root it. Notice that the square disappears because we're square rooting this side. So if you have a good calculator, if you don't have one, I have some up the front there, right? You know where they are. On the ledge there, so 7.6 squared plus 9.4 squared, that's 146.12. Over there by the, yeah, 146.12. Square root that. It's 12.09. Okay, 2 decimals, always your final answer, 12.09. And we are in centimeters. So you're going to be able to practice it in a bit. So for now, maybe just write it down. I'll give you another example here. You're going to have to copy this diagram just real quick. It wouldn't take that long. So let's draw it right here. This is your 90 here, even though it doesn't look like a 90. This is 17.8 inches. And this is 12.6 inches. It's asking you to solve for that side. Just write that down real quick. I should use a ruler probably, right? Next time. Let's see if I can fix it. There you go. Okay, so pay attention. I find the hypotenuse. I start with the 90. I go across. This is my hypotenuse. No problem. That means that this is a leg and this is the other leg. So this is the scenario where you're missing, you have an unknown leg. So you have to start like this. Leg squared is equal to hypotenuse squared minus the other leg squared. So it's kind of like assume that it's the one you know, right? So leg, which you have no letter for, we can call it x if you want. Let's do that. Sorry, messing up your notes. Let's call this x is equal to question mark. So we're going to say x squared, this side squared, is going to be hypotenuse squared minus 12 points. That's the biggest difference between them, right? That you have to subtract. It has to be the hypotenuse minus, otherwise you'll get a negative. You cannot take the square root of a negative, right? So I type that in, 17.8 squared minus 12.6 squared, 158.08. And so I will go square root of that answer, 12.57 inches. It's shorter than the hypotenuse, so I'm good to go. Right? I will highlight the minus, right, because that's the biggest difference there. And maybe highlight the plus on the previous example, right? So blast from the past. I hope you're like, yeah, this makes sense. I hope I'm gonna come around, and so I'm gonna get you to practice this on the next page, 176. There are 3 examples there. Try to do at least the first 2. I will do the third one. If you can get it to the third one, great. If not, that's okay. Just try to do the first 2. Try to solve for the unknown side using Pythagorean theorem, okay? I won't give you a whole lot of time because that's not what today is all about. It's just a refresher on how to do this. Anybody know what's up with Solomon? Here is the hypotenuse, which I see a lot of you is like, label that. The other one I actually don't care too much, but the hypotenuse is important. So this is a y squared is equal to 69.3 squared plus 47.6 squared. The next line I would like you to show is just what is this and put it under the root. And I'm just going to go my key here, 70, 68, 25. So that is 8407. And we are in centimeters. Make sure you add your units. You know what? I think everybody got that one. Maybe a few hiccups here and there. Way to go. This one, identify this as my hypotenuse. Immediately you know that you're going to have to go a squared. This is the one you want. You're going to have to take your hypotenuse squared, subtract the other leg from it, right? So yes, there's no damage done if you label that, right? So then that gets you 6,021, no decimals. So 77.60 millimeters. 0.6 is fine because it's not a dollar amount. 0.6 would have been fine there. No deductions. I'm just so used to, and I want you to get used to 2 decimals, and you'll never go wrong. Okay, this one is a bit of a tougher cookie here. So you have to pay attention because this could come up, okay? When you have 2 like that, they share a side. Watch this. They share this side. So it's gonna be like, I need to find that to get to the other one. So you pick between these two, and I would pick this one, right? I would pick this one because you have 2 sides known here. No letter there, right? Give it a letter. X, right? I don't know why it's always X, but anyways. That's the one you want to find because they share that in common. So based on this triangle, this is your hypotenuse, right? So this is a leg and that's a leg. So for the first triangle, x squared is going to be hypotenuse squared minus this other leg squared. Okay, because this is a leg for this triangle. Then x is going to be square root of 3,331.69, and that's 57.7208. And you're like, why 4 decimals? Because I'm not done yet technically. It's okay if you do 2 decimals. I'm going to let it go, right? But technically you wouldn't want to round here yet. Now you found, right, this, I'm going to highlight this because this is this side right here, okay? That's the one they share in common. On this triangle here, you're missing the hypotenuse is across here. This is the hypotenuse. You're missing P. So P squared is going to be leg squared, right? This is one of the legs, and this leg squared as well. So P is going to be square root of 5531.3, and that is 7437. This is my final answer. This is what they actually wanted, right? So I circle that. So this is a 2-step, right? 2-step example, right? If you need to, I will add this here. Start with triangle that has the most info. Okay, that's the key here. Start with that one and then move over to the other one, okay? Now I'm going to skip a bunch of questions because they want you to review SOHCAHTOA, and I'm not going to do that, right? I learned my lesson. I used to do SOHCAHTOA, and then I got all mixed up at the end, and it just was ugly. All right. Let's keep going. So I'm going to skip a bunch of pages, and I'm going to go all the way to 179. Okay, 179. So this is what today is technically all about. 179, kind of like in the middle where it says new skills. And I want you to, in like capital letters, put a title to this. So we're going to put classifying classifying triangles, because if I ever ask you to, go review how to classify triangles, I want that to stick out. If you have a highlighter, then I would do that as well. So that when you flip through, you're like, oh yeah, classifying triangles right here. And here it is. Property is a characteristic. Let's get to the same page as my key here. Classifies and distinguishes between your objects, so between triangles. Like if you classify, you distinguish it from the other ones. And here it is. Triangles can be classified by their angles and their side lengths, right? Just underline side lengths and angles, right? Those are the two ways that we classify a triangle with. And I know that some of this is going to be like I did this in grade 7 or something. Some of this will be, but it will get a bit tougher down the road. So I would like you to box this in because it's very important, right? And they're usually not going to take you very long to answer, but you need to know your stuff, right? So if you go by angle measure, then there are 3 options that you can put a triangle into, 3 categories. It could be an acute triangle, which means all 3 angles measure less than 90, right? So it will look like this. It could be a right triangle. Obviously, that shouldn't surprise you. The one that gives it away is the 90-degree. If that has a 90, if the triangle has that symbol, you know it's going to fit into this category immediately. You don't have to wonder. Obtuse, it has one angle that measures more than 90, so it'd be this one right here. Okay, this angle right there measures more than 90, so immediately it falls under the obtuse category. Okay, so these are the 3 categories. If you had to put it, categorize it by angle measure, these are your options. Okay, and I will add a little bit more to it in a bit. For now, follow me to the next page. I wish they had been on the same page. Okay, 180, box this in as well. If you have a highlighter or a pen or something, just circle it or make it stand out. Okay, and you have 3 options here: equilateral, isosceles, or scalene. Equilateral, 3 sides are equal, right? And the 3 angles are equal. 3 sides, 3 angles are equal. So this is actually in particular all angles. I'll make a note here. Let's go arrow out to this side here. All angles measure, what is the degree of the angle of an equilateral? They all measure the same. 180 divided by 3, 60, right? 60 degrees. So equilateral is always acute because they isosceles, there's 2 sides of equal length and 2 angles of equal measure. Okay, and that's denoted by the markings like that. Okay, so I want to add something here. If you have a color like a red pen or something, or blue, notice this. If these 2 sides are equal, then automatically the angles across from them will be the same. So if one measures 10 centimeters and 10 centimeters, whatever the angle is, it's going to be the same. Okay, so keep that in mind. Scalene. Scalene is, watch this, all sides are different, no angles are equal measure. Okay, So they could have said all angles and all sides are different in measure. That's what they could have written to make it easier, right? So there you go. So watch how would you tell by looking at a diagram? If there are no numbers attached, watch the markings. It would be like this. If the sides are marked like that, you don't know what the number is, but you know that they all measure like different. So 1, 2, 3 like that, it's different, right? 1, 2, 3 like that, it's a scalene. We automatically assume it's scalene, has different sides, right? To summarize, we're going to go back again to 179, and I'll just put this in a brief little diagram, not really a diagram, but if you need to categorize by angles, you have acute, you have right, and you have obtuse. Right? If you just look at the angles of the triangles, and if you look at the sides, you have three options. You have equilateral, you have isosceles, and you have scalene. Okay, so make sure you have, unless you're going to remember, this would be a good entry to your study sheet, right? To have those, like, because every triangle, folks, every triangle has a first and a last name. That's what I say, a first and a last name. So to classify this triangle, if you only say right, but you don't put it into one of these categories, then it's not complete. You haven't answered the question. So it could be an acute isosceles, right? It could be an acute scalene, and so forth. So it's always first name, last name. It doesn't matter if you flip it to me. It doesn't. It sounds weird, but it doesn't matter to me as long as they show up, right? No English teacher, right? Even if your sentence, if you misspell, as long as you answer and it makes sense, that's all I look for. All right, so now let's fast forward again to page. I'm going to ask you to go to 181. There's a blank page there, and you're going to have to copy a few diagrams down before we continue. So 181. Go to that page and then just write down the diagrams, okay? So we're going to call this classify the following. This book had nothing on this. It just jumped right past it. So I'm giving you some examples of what you're expected to know. A, just markings. Some have markings, some have numbers, and you need to make sure if there are numbers that you use those numbers to get you more information. Some are not drawn just like the way they should be, but this is D. Make sure you write these down. So write those down, copy them, and then I'll go over them. Think about it. What would you do if I give you an AC right now? It's like, hey, classify this one. What would you give this? Don't tell me, just write it down at least. This. Is there a volunteer that would like to say this is what this one is called? Right isosceles? Yep, you're right. And so this is what I would have wanted you to do. You look at this, like this side is the same as that one. So if this is 45, then I'm going to take that other side that's equal and travel across and make sure this is 45 also. At that point, you should have recognized that this is 90 here, which is denoted by that little box. So everything in red is added, right? So this is a right isosceles. Isosceles. Sorry. There it is. It's a right isosceles. There it is. You got it. Cut this in half now. Or just make sure there's a line, because I'm going to up it a little bit more. So here, what if you had something like this that has, this one just has more going on, just busier, okay? If you have that, this is 3.5 inches. This is 3.5 inches. And this is, let's say this is 120 degrees. And I'll put letters in there, D, E, F. So you're not, that shouldn't throw you off at all, okay? But what if you had something like this? No markings, right? But if these two side lengths are the same, you just go put those markings in there, right? Put those markings in there, and then you're basically saying it's isosceles. And because of this here, it's going to be an obtuse isosceles. Okay? And so today we're going to just focus on reading a triangle and just doing some basic calculations to label it. Starting tomorrow, we might have to use sine law, cosine law, and stuff to find out missing pieces, to actually calculate them to know for sure. Okay? All right. So I want you to grab your booklets and you work on this for the rest of today's class. So it goes from page 3 all the way to 5 in the workbook. You should be able to answer these types of questions tomorrow on an AC if I give this to you, okay? The key to this, you don't have to ask me, the key is just right after it. Just keep going to page 6, 7, and 8, and the answer key is right there. I would say don't peek just yet, because the classifying is very easy to check later on, okay? So you have 20 minutes. How about you get this done, or do as much as you can, and then you don't have to worry about getting ready for tomorrow, right? Because you'll know it.